we are going to have the discussions on non-destructive testing. One of the foremost in non-destructive testing is the penetrant testing. It's one of the very basic and uh, very easy process to know the feature of a material, the quality of the material after it undergoes various sorts of forging, welding, structural changes, heat treatment, and so many other areas which we will be discussing. Now, when we go to the next slide, it's actually about me, about the presenter. I have more than 40 years experience in welding and NDT, and I have been associated with ISNT and BIRC, Bhava Atomic Research Center activities. I have decades of hands-on experience in NDT. I've been associated with major approvals like NPCL, Nuclear Power Corporation Limited, RDSO, Research Design and Standards Organization of the Railways, the Director General of Civil Aviation. This is a very critical approval they carry on. Then the Director General of Quality Assurance, DGQA, and Director General of Quality Assurance for Navy, DGQA, Naval Approvals. I've been associated with major engineering colleges like IMU, Camellia, MSME on NDT seminar. Now, looking back, let us have a peep into the history of penetrant testing. As I told you, that it's a very simple process. At the same time, it has not just come from a striking of a lightning or something like that easily. It is a process which has developed over the years, and the first penetrant testing process known to us started in early 19th century. Mainly chalk and kerosene was used for flaw detection. First known use was in railroad and later into the automobile sector. Also to that extent, to some way, even the defense sector also was involved in this. Now, the point of concern was how to best see the surface defects as it comes onto the material. Red was chosen, red dye was chosen as red provides the maximum contrast, and fluorescent material, fluorescent penetrant, as green yellow for a high brightness, because here we use a UV lamp to see the flaws. Now the use of penetrant testing was associated with fabrication industry because of its portability. Portability is one of the most important factors in penetrant testing, and historically it got developed into one-to-one situation. Now let us look into the basics of penetrant testing. It is very important to understand this because if we are clear on the basics, then we will be able to understand non-destructive testing very closely. This is used on all materials except porous ones. There is a procedure of pre-cleaning. This is a very important point in any NDT testing mostly, but specifically for penetrant testing where we use mainly the dye and the developers, etc. Now, why pre-cleaning? Pre-cleaning is because if we do not clean, degrease, or remove dust, dirt, etc. from the surface, then we will be not easily seeing the flaws. We cannot check the flaws very easily because this dust, dirt, grease, or oil, or whatever it is, it stays onto the surface and prevents the dye to enter and check the areas where such type of flaws have occurred. Next is the penetrant application. Penetrant application is an important part, though it may seem to be very easy that we use a red penetrant or a fluorescent penetrant, just uh, dip it into a bath or use some aerosol can. It's not a very simple, easy process. So, proper way of penetrant application is a important part for the basics of penetrant testing. Now, more so comes the excess penetrant material removal. Now, wherever these flaws are there, the penetrant has entered into those flaws so that we can check the areas of the flaws. Now, if we overdo the penetrant removal, directly spraying onto the surface of the job, or removing it, trying to removing it by some mechanical methods like grinding or something like that, this excess penetrant can be removed totally, and we will not see any sort of flaw defects. But at the same time, if we do not remove this penetrant properly, then in the entire area will show as if there were some sort of surface defect. Next comes the use of developer. Developer is actually has a skill part in application, mainly when we use the developer on two surfaces which use the aerosol can. If we directly use it very near to the surface, then there are chances that lumps will be formed and we will not be able to see the proper flaws which actually will be there on the surface. So, use of developer requires some practice and skill for doing so. Now, in order to undertake these penetrant testing, generally certain equipments are used across the world for certain areas to check its use as a comparator or as monitoring system or the sensitivity. We use a ACA panel or an aluminum comparator panel to check the testing part of the life of a penetrant, whether it is acceptable or not. So it is a comparator panel. We can compare two types of penetrant, or we can compare two types of same penetrant, but to various maybe production dates, or a unused can. We do not know what are the issues in why it has not been used for a long time. We can check back and find whether it is appropriate to use such type of penetrant. Then we have a PSM panel, or maybe some people say it as a TAM panel. It is actually a penetrant system maintenance panel. Actually, when we go deep into this study, we will find that major major parts components, particularly in heavy earth moving equipment, or in aircraft industry, railroad industry, uses these panels to monitor the penetrant system, the penetrant, the whether the grease, dust, dirt of has actually perpetuated inside it, and actually made it not possible for uh, testing. And last but not the least, it's a very important part to actually have a check with a nickel chrome panel for sensitivity. Nickel chrome panel comes from a depth of crack of zero point 0.5 micron to from 5 micron to 50 micron depth. But the thing is, for penetrant, red dye penetrant, we generally use from 20 micron depth sensitivity, and for fluorescent penetrant, you can use 5 micron nickel chrome panel. These are generated cracks on nickel panels, and a slight coating, a thou coating of chromium is put onto this nickel, so that it doesn't get tarnished very easily. As we know, nickel is a very ductile material, and therefore can be tarnished. So that is why chrome is actually plated on that. So it is called a nickel chrome panel, and sensitivity ranges, as I told you, from 5 micron to 50 micron depth can be tested with this nickel chrome panel. Now moving on to the next part, the standards and major approvals of penetrant testing. See, it is not that just like that people use this penetrant testing. There are standards, there are major approvals for which, particularly in India, which and internationally, which are actually used to have these guided, so that we know whether we are actually utilizing this material in a correct form or not. So ASME section 5, boiler and pressure vessels code, is one of the first guide for, and a very important guide for penetrant testing. Then we have National Board of Inspection Code, who also guides us for such use of penetrant testing. Nuclear Power Corporation Limited in India has their own standards, and their approvals are very critical and useful for use in nuclear power stations across the country. As you might be aware, that nuclear power uh, use, the flaws, if it at all is there on any structurals or whatever components are there, then if there is a flaw, then it can be a major defect in the area, and it can create havoc to the entire population. Now coming to the next approval is the RDSO, as I already discussed, mainly for railroad industry, but this RDSO specification is undertaken in many other industries so that they follow a certain specification. It is very, very highly effective way of that has been designed for penetrant testing. Similarly, Engineers India Limited for various projects at project sites, they have these major approval standards for penetrant testing. Bharat Heavy Electricals Limited, BEL, has their own type of penetrant testing and at sites, and they are being used regularly. Now,